Hello, friends. Welcome back. So we are going to move on to the next step. So till now, I think let's do a quick recap. So we took the data from Kaggle. We first got introduced to what we're trying to achieve as a part of this movie lens project, and we saw the initial CSVs that we got from the Kaggle website. So and we understood the structure of the data. We saw that they were mainly a bunch of CSV files, and some of the columns were there in the CSV were actually complex JSONs, right? So we covered all that. So then we wrote a bunch of Spark programs to take that data that it was in this complex CSV format, and we shredded them into more of a relational format where you can actually see the different entities and relate them from one entity to another using like link tables. So we did all of that using Spark, and we created a bunch of files in the Parquet snappy compressed format. Then, just to demonstrate that it was shredded correctly, so we took the data and we actually loaded the data into Postgres that was running inside Docker. So we completed till line 20 here. This was the Docker run command for the Postgres. And if you kind of switch back here, you can see that the Docker Postgres is running. And we loaded the data and executed a bunch of queries. And we kind of saw that the data was there, right? So let's take it to the next step. So traditionally, the other side, what we have done is we have taken this data, uploaded it into a data science virtual machine that is available in Azure. That is straightforward, and it has a lot of libraries that are required for Jupyter already preloaded. So you have to do pretty much nothing. You upload the data and you can start analyzing it. But if you want to do that locally and don't want to spend some money on Azure, so this is what I'm going to kind of show. So the same thing, what we will do is try to run the Jupyter notebook. So if you look at the command 24 here, it's going to actually load this image, Jupyter slash all spark notebook. So I'm going to copy this command and actually make sure your Docker is running. So when you do that, you'll see this green button here, and then in my case, it's actually running because I should see a container running too. So you go back to the command prompt here, and then we do dir just to say that we're in the right spot, the same spot that we were in before, spot examples. Then we do docker ps, then we will show that it is the docker postgres is running. So now we execute this command. So what this is going to do is it's going to docker run. It's a new container. Minus d is detached, name is Venki notebook, and what here we are forwarding the container 8888 port to 10,000 outside it. So we can actually hit the browser on 10,000, and it will actually go into the container on 8888. And this is the actual image we are going to run. So if we hit enter, it will start off the image. So this has got pyspark and all those things. So it is going to take a little bit more time when compared to Postgres to launch. So if you can do docker ps, you will see, this the first one is a Jupyter Allspark notebook, and you'll see the health is starting. So typically it takes like about 20 to 30 seconds, and it will come back into the healthy state. So if you see here, now you can see it's in the healthy state, right? To connect to any Jupyter notebook, you need a token. So to get the token, you actually need to inspect the logs. So in any container, if you want to see the logs of a container, you just do locker logs and the name of the container. Now, because it's Venki notebook. So if you kind of see here, it is telling me that is the token, right? So all you need to do is copy this HTTP localhost 8888, copy that, and go to the browser. Open up a new tab, and then you hit the control V. But the only thing we have to change here is not 8888 because we're forwarding to 10,000. So you're going to put 10,000 and hit enter. So once you do that, it will launch the Jupyter notebook. So what I have done is actually I've tried to run once so that I don't waste too much time. And I've created the notebook and it is all kind of ready to go. So I can kind of show you this here, and we'll upload and start working. So if you go here, there's like a movie lens processed explore local test IPNB, right? So that's exactly what we want to upload. So if you go hit here and hit the upload button here, it's going to jump into this screen, and all we are trying to do here is the local, right? Movie lens processed explore local test. And this movie lens processed explore is actually for the Also, dataset, data science VM. When you provision the data science VM with the RM template, we can actually execute these. So let's click this one first for this example, and it'll load up here. So we can double click on that, and it'll launch it. You can kind of see that it launched, right? So before we do anything else, we need to actually copy the data that we shred using Spark and actually upload it into the Docker container. So just to quickly demonstrate here, right? So I'll add a plus button here, and if I do exclamatory ls, that is going to list all the data, all the files that are there. So this is the uploaded file, and then this is the work directory. So this is the same exact directory here, right? So what we'll do is we'll do the docker copy command, and we'll move or copy all the files that we created in Spark into this Docker container. So we could have done it with a mount and other things, but just to keep things very simple, we're just going to copy the whole thing, right? So we got the token, etc. So now we're going to copy, right? So Docker copy. So this is also all these files, shredded files also are on the in the repository. And when you check out, it'll be in this path, like is Azure DP03 WRWI02 movie lens. So all we are doing here is we're copying that into the Venki notebook container and into this path. So home, Jovian, movie lens process, right? So we're gonna execute that command here. So we come back here, we go to the screen, then we fire this command. So all it's doing is copying it from the local into the container. Now when we go back to the container and you execute the same command ls, you will see that there is a movie lens processed folder. So now if you want to do movie lens, you'll actually see that there are different directories, and inside each of these directories, let's pick one and then say movies, and then you will see the actual snappy parquet files. So this is a snappy parquet file that is sitting right there in the movies, right? So that's the first. So then what we have to do is the data science VM, it actually does a lot of things behind the scenes for us. So we don't have to go through a lot of steps, but this is open source, and it's not already configured. So what we have to do is a bunch of extra steps that we would not have to do on the DSVM. So the first thing we'll do is install this pip command, the find install pip install find spark. If we execute this, it's going to run and it's going to collect it and download it. And then this is a successfully installed find spark. So then what we do is we actually import that, and we'll call the init method. So it'll actually go and find the actual Spark install that has happened inside the Docker container. So it won't show anything. It'll just run and jump to the next step here, as you saw. So now using that, we have to import the pyspark, and then we actually have to create this new Spark context, right? So we execute that, and it will actually print the Spark context. See, it loaded that. Whenever you see something running, it will be in the asterisk here. So it will print the Spark context. And using the Spark context, now we have to import the Spark session, and we create the Spark session, right? So we fire that off, and then it can see that it printed the Spark session. So that is, this part is not required on the DSVM, but after that everything is exactly the same. But only thing to remember in the DSVM is the path is in the home Venki user, because that's how it's provisioned when we provision with the ARM template. But here it is fixed. It is in the Jovian, and there's no easy way to create it a new folder. So that's why I just put it right there, right? So this is what we're reading the markup file and just printing the schema. So we'll execute again, and it is going to run. You can see it's running here. It will print the same thing. So this is your movie IDs, adult budget, etc. You can see the shape of the data, right? So then we'll just do a count setting. So it'll run through, and it will basically show us that there are 45,000 movies in here, right? So this is the next one, genre. So the genre, we just we're trying to figure out, what is the genre and the ID and the genre name. The same thing we saw in Postgres. So if you run this, it will print the genre name, and it's a war films, adventure films, and etc. stuff like that. So then we will jump into the genre movie. This is the link table, so we can run that one more time. And it will basically say this particular genre is this movie, right? Now 862 is in three different genres here. And 8443 is in a different genre, right? So it will give you the link. So then we'll do a join. So in this case, we are doing a movie genre join genre. So this way you can get the movie and the genre together into denominalized format. So we ran that and it is printing the schema. Now if you see here, pretty much all that has happened here is this genre ID has joined the genre ID and then given the genre name here, right? So then we'll move on and then we'll try to kind of integrate pandas with pyspark. So this is a pretty cool feature where you can actually use the pyspark data sets, and then you can actually convert them into pandas data frames by calling this method to pandas, and then you can actually do something like a plot, etc. Right? So this is a very cool example. So if you execute this, it is basically going to print bar chart, and all this is doing is it's just counting the number of movies by genre, and you can see drama has the highest number of movies. Almost half of the movies are drama, and then it kind of ramps down to smaller and smaller sites, right? It's just exploratory analytics, nothing groundbreaking we are doing right now, but just kind of getting our feet wet and understanding, so that we can move over to more complicated ones, right? So here also we're going kind of doing the same thing. We're doing collections, movie collections, and we are analyzing the what kind of collections are there, right? So we'll fire this one more time, and then it's going to plot graph quickly to see these are the collections. These are the number of collections, number of movies in each collection, and you can see these are all. James Bond collection has about 25, more than 25 movies, and you can kind of see there are a lot of some collections have a lot of movies, kind of slowly dwindles down. Just want to make sure that you do only a head of something, right? Because if you don't do it, it will become a very huge graph. So moving on to the next step, we're going to just do cast and crew, some kind of analysis to say who is the cast